Hey Algebra 2, in this video I'm going to be talking about section 5.6, which is inverse relations and functions. So before we introduce inverses, we should remember what a relation and a function are. So let's remember. Relation, which kind of sounds like relationship, is a collection of ordered pairs. A collection of ordered pairs. Equations are also relations. It kind of has to do with that term relationship, because in order to get your y value, you need your x value, right? So they have this relationship with one another. Then let's remember the word function, which we use a lot, but remember the definition of a function. It's a relation. So it's already an equation. It's a relation where every x has one and only one y value. Every input has one output. So a function is always a relation. A relation is not always a function. So what's new is inverse relation. So an inverse relation is a set of ordered pairs found by switching your x and your y values. That's going to be important. That's what we're going to be doing when we're figuring out an inverse. If an inverse relation of a function f is a function it is the inverse function. And we note it f and an exponent, if you will, of -1 of x. And this is read f inverse of x. So, excuse me. Let's do an example. Alright. What is the inverse of the relation represented in the table? So first, here is your xy table. We're going to do -2, 1, -1, 4, 0, 3, 1, 1. Okay, so that's everything you are given. So the work, we want to know what the inverse is. So we're going to make a table x, and then it's negative, or sorry, not negative y. It's y to the negative first is the notation for inverse. So that means inverse. Just like here, the difference is this is a function, this is not necessarily a function. If you remember, to get an inverse, it's found by switching x and y. So all my y's are not going to be my x's, so it'll be 1, 4, 3, 1. And this will be negative 2, negative 1, 0, 1. So we're just switching the x's and the y's. And then it says, what is it? So here's what it is. And this is a function, right? Every x has only one y. But this is not a function because the input 1 has two different outputs. So this is not a function. Okay, another kind of problem you can have is algebraically determining the inverse. So we could have a problem like this, determine the inverse equation of y equals 8x minus 13. Okay, so when we are doing this, we'll start with the original equation. Okay, and then remember, you need to switch x and y. So this is now going to be x, and this is now going to be y. So we switch x and y, and now we're going to solve for y. So I'm going to subtract 13, add 13. And then I'm going to divide by 8 to get y by itself. So here we just solve for y. And then we're going to rewrite our equation. We're going to rewrite it using the appropriate notation. So because this was y equals, this is going to be the inverse of y equals x plus 13 over 8. And that's the inverse of 8x plus 13. So to find an inverse, to recap, whichever way you're doing it, you're going to switch the x and the y. And then if it's a table, it's just done. You just switch it. If it's not a table, you need to algebraically solve and then rewrite using inverse notation. And you'll notice in our table we also have inverse notation.